And I'm Mike Bollinger.
And we are going to play the song matching game that we made in lab. We built this circuit to sense who wins the game by using a stepper motor to change the position of a flag such that a photoresistor on either side of the breadboard will be covered up. And this will indicate whether player 1 or player 2 wins. And the way that this works is that we have two mini circuits here, one here and one here. They have the same ground, but a separate power is going to each one, and that is controlled by our DAC, which is outputting 5 volts. So this is another example of using a shunt resistor, and we have a shunt resistor here and one here as well, and then we have our photoresistors. So when we cover up the photoresistor, the resistance increases. So that means that this photoresistor is going to have a higher voltage drop than the shunt resistor. So the shunt resistor will have a lower voltage drop. And the same holds true for this one over here. So if we go to our VI in our photosensor sub-VI, we can see how that translates into telling the VI who has won the game.
So we're going to explain one of our sub-VIs and then one of our sub-VIs inside of the sub-VI. It's a little sub-V inception. little joke for you there. So here's our photosensor sub-VI. Right here we've got our error in and our error out, and that gets tied through all of our sub-VIs to make sure all of the error is the same. We have two DAC assistants. One of them is going to be for player 1 photoresistor, the other one is for player 2 photoresistor. What this does is it just monitors the voltage drop across the photoresistor. When that voltage drop goes below 2.5 volts, it'll tell the Boolean indicator here true, and when it's true that means player 1 has won, and if player 2 is true then it says player 2 is true. If we run this here, you can see the voltage across both player 1's photoresistor and player 2's photoresistor is the same, but if we were to cover up one of them, the voltage drops well below 2, and so that would indicate that player 2 has won. Or on the other side, we cover up the photoresistor on player 1's, player 1 would win, and it shows true. Now if we stop that and we go up a level to our stepper motor, this is what's going to tell our stepper motor and our flag how far to go. Right here under numeric, that number gets input into our for loop, and that will tell our stepper motor how many steps to take. We get that number from an input of the player's score when they either get 1, 2, or 3 when it compares their tone to the made tone. And we take that 1, 2, or 3 number and it gets multiplied by a constant, and then it gets input here. And that number comes from our main VI. And then down here is our direction, and that direction is either a true-false indicator, and that comes in from if it's player 1's turn, this is true as it goes through. If it's player 2's turn, it is false. These 3 DAC assistants are connected to our stepper motor controller. The first DAC controls how many steps it will take, and then DAC 2 and DAC 3 are both directional. This will be a true for player 1, it goes in that direction. This one is a false indicator, and if it goes that other direction for player 2. Coming out of our photoresistor sub-VI, you can see that we have 2 different Boolean indicators. One goes up, if it is true, it'll say that player 1 has won, and if it is false, it'll say that the limit has not yet been reached. On the same side for player 2, we've got player 2 wins, or the limit not reached there. We're going to run this real quick so you can see the stepper motor travel a little bit. We'll click this up to 200, so that should be a half rotation. Now if we run this, you'll see this flag travel one direction or the other, and as soon as Katrina sticks her hand over one of the photoresistors, it will shut off. Alright, here we'll change the direction, and then we'll see it go the opposite way. Perfect.
This is the master VI that controls the entire sound matching game. It begins with a while loop, and the first thing that we have here is a sound match sub VI, which has the computer output a tone that the players try to match. And the graph that is shown on the front panel gives a graph of your voice and compares it to the target tone. So we have indicators here that compare the frequency of your tone versus the frequency of the target tone. We also have an indicator which shows which player's turn it is and the score that you receive for how closely your tone matches the target tone is indicated here. On the front panel we also have a dial which can be changed by the players to change the time between the tones. And this basically serves as a time delay for the loop. So this is in seconds, we multiply it by 1,000 and it goes into this icon, and that will give a greater amount of time before the loop runs again.
Coming out of the sound match sub VI, here's your target tone, and that's what gets displayed on the front panel. And here is your tone. Again, that just displays that number up on the front panel. These are orange, showing that they are floating points, they aren't integers. Coming out of the sound match game also, once it compares and it says what your score is, obviously there's an indicator on the front panel of your score, but to move the stepper motor, we take that score, multiply it times 5, and then it goes through, and that's what goes into our stepper control sub VI and tells the motor exactly how far to go. So when we were talking about the sub VI here and that numeric icon for the input on that loop, that's where it comes from. Now you notice that we have this weird 100 constant and a 1 constant. The 1 constant is just, we ended up having to add that in, so no matter what you get, even if you get a score of 0, it adds 1. So that stepper motor will move one step, which is very minimal. It doesn't help you game-wise, even if you don't score any points. The reason we had to add that in is because if we had a 0, if you scored 0 points, like I did a bunch, it goes through and it's a 0, and what ends up happening is it goes into the stepper control, and if it says it's a 0, that sub VI, that loop won't run all the way through, in which case you end up getting a weird error where it doesn't say limit not reached and it doesn't say player 2 or player 1 or whichever one was covered up. It just gives you a blank screen. And so if we added 1 on there, it would actually run through the sub VI, really not giving you any kind of advantage, but at least it would make sure that would run through and then keep the whole thing moving. We also have an override control. The override direction is right here. We actually minimized our other override control so you can't see it on the front panel. But that override direction is just so once the game is over, you can tell it to move one way or the other. Once this is on, it'll just move the stepper motor so you can get it back to the 90 degrees and straight up in between the two photo sensors after a player has won. The only other thing to talk about on here is this little iteration guy. To switch back and forth between player 1 and player 2, this iteration goes through, you have the 2 coming in as well, and then that'll tell you it comes out as true or false. If it comes out as true, that means it's player's 1 turn right now, and if it's false, that means it'll be player 2's turn. And so that, just the iteration on the loop, kind of controls it and it goes back and forth. And to make sure that it stops automatically, we have a little true or false coming out of our stepper control. The top green wire is a boolean and it is true or false for player 2 whether or not they have won or not. The bottom one's true or false for whether or not player 1 has won. If either of these is true, this is an OR control. If player 2 is true or if player 1 is true, it'll go through and it'll stop the loop automatically, ending the game after 1 has been covered.
Purposely went on. Still didn't. That was off on that one. I knew it. Staved off the feet. defeated. I think this game is gender biased.
Pretty clearly so. Or not. Okay, so now you can stop up there. It'll stop and
I
then.
don't want it to stop because I lost. It would be a bad loser.